Hello? Okay. Can you hear me? Anybody?
Yes.
Okay.
Yes, we hear you, Professor.
All right, great. Got a little technical bug there. So, was the test as expected? Easier, harder, what? What's your initial impression?
It was real cute, Professor. It was cute.
Yes, it was.
It was cute. It was cute.
I actually was happy, Professor, how it went, how it was.
Me too.
Okay, so cute is a good thing.
Yeah, cute is real cute.
Your, I didn't hear what you said, Stephanie.
I said I wasn't, of course. I mean, the test was good, but me and my usual self.
Mm-hmm. All right, well, we'll look it over and that kind of thing. I'm sure as long as we're trying our best, we can work with you. We're trying our best, and that's what we're going to do. So I don't want to keep you too long with this lesson because you've already expended a lot of energies and efforts and everything. So I will want to share somebody's screen at some point, either Stephanie's or Freeman's.
I can share mine, Professor.
All right. So the one topic today is scientific notation. Is anybody kind of familiar with that? Does that ring a bell with anyone? No? Freeman, no? Okay. So we're going to use this for very large or very small numbers. Very large and very small numbers are when we use scientific notation. When you study biology and you learn viruses, when you study viruses, they are extremely small. And so the numbers you're going to work with will likely be in scientific notation. If you ever study any subjects that deal with space, and if you deal with light speed, extremely fast, extremely large numbers, those are other instances where you would deal with scientific notation. Or even when you are trying to measure the distance of miles between Earth and the moon, for example, huge numbers. Those kind of numbers will also use scientific notation. Now, you normally see numbers the way they look on the left, like 983 million. Large number. Large numbers with these commas here, that's standard notation. The number on the right, scientific notation. So you're going to see just a short amount of numbers times 10 to some exponent. So this is the short version of this number. So scientific notation is a short way of representing a large number or a very small number. So I'm just showing you what standard notation looks like as opposed to scientific notation. Is that okay so far? Any questions yet? Bekelu, can you hear me, Bekelu?
Yes, Professor.
Okay. Carol, you hearing me okay?
Yes.
And Taylor, that's fine, Taylor? Okay, thank you. Good. So, two things we're going to look at. We're going to convert from the standard form to the scientific form, from standard to scientific. And that's what the homework is going to be doing as well. So there's 3 steps. First, you're going to move the decimal point so that the first integer is between 1 and 9. Move the decimal so the first integer is between 1 and 9. What's wrong, Taylor? Oh, all right, okay. You're going to count how many places the decimal moved. If you count left, it's going to be a positive exponent. If you're counting going to the right, it's going to be negative. Then you're going to put the times between the number and 10 to whatever that decimal point is. And we're going to try some examples. So 3 steps. Move the decimal. So it's between, the first number is between 1 and 9. Count the number of decimal places you moved. And then you're going to put an X in between the number and 10 to whatever the number is of the places that you moved. If you're going left, it's positive. Going right is negative. So when you have that copy, I like to do a couple examples. So I'm going to write convert from standard to scientific. Okay, are we ready, Stephanie, you think?
Mm-hmm.
Okay, Taylor, you need a few more minutes, Taylor? Okay. All right, so we're gonna start, Taylor.
Professor, I can't see like.
Is that better?
No, I just can't see because the box so little. All right, I can see now.
Okay, let me try this. Is that better? Just hang on, let's give Taylor a few minutes to write this down. Our time is good. We have 17 minutes. That's plenty of time. I'll ask you this, Freeman. Can you get your Canvas page ready? So when we are ready to share your screen, you'll be good to go.
Yes.
And say when, Miss Taylor.
Professor, you can go here. I just had to get somebody else's notes. I can't really see because it's like I don't know. It's different from the last to how it usually be.
Wow, I'm sorry. I don't know why.
It's okay. Go ahead.
It's okay? All right.
Yeah, go ahead.
All right. So this first number that we're going to convert, 14,200. This is in standard form. So when something's in standard form, you may not always see the decimal place. So in this problem, where is the decimal place?
Behind the 0. The first 0.
It's right here. It's behind this 0. So the instructions say that we're going to move the decimal so that the first number is between 1 and 9. So we're going to move this decimal over here. We're going to put it right after the 1. So I'm going to have 1.42. And then we're going to put times 10. And then we're going to count the number of places that we moved That's going to be our exponent. So we will have 4 places that we have moved. So this, it will be our number in scientific notation. Whenever you have something times 10 to an exponent, that's scientific notation. And the first one was standard.
Professor,
Yes,
how you know to move the decimal between the 1 and the 4?
because the very first digit, this first digit, this number, it's got to be between the 1 and the 9. So if I put it by the 4, then that'll be 14. That'll be too large of a number. So you want just the very first, whenever you use scientific notation, you just want the first integer. That's where you're going to put the decimal, after the first integer. So this first number here has to be larger than 0 and less than 10. Does that answer your question?
Mm-hmm. Yes.
Okay. Let's convert this number next. 0.0042. Now this is a small number because here we see the decimal. When it's a large number, you don't see the decimal because it's after the it's really after that last 0. When it's a small number, you are going to see the decimal, and the object is the same. You're going to move this decimal so that it is past the first number. So in this case, when we move the decimal, it's going to be between the 4 and the 2. So we got 4.2 times 10, and we got to count the number of places that we moved. So when we're converting from standard to scientific notation, when we count to the right, 1, 2, 3, counting to the right, the exponent is negative. When we move to the left, the exponent is positive. So again, this first number, this first integer, has to be between a 1 and a 9. So we move this decimal right in between the 4 and the 2. You still have to use the 2, but this first number in front of the decimal is just going to be 1 digit between a 1 and a 9.
And you say to the left is negative?
When we move the decimal to the left, it's positive. When we move the decimal to the right, is negative. That's when we're converting from standard to scientific. Now it kind of works the other way around, where we're going from scientific to standard. Let me show you what I mean by that. How's our time? Our time is good. So we're going to convert from scientific to standard. So when we're converting the other way around, exponent is positive, we're going to move to the right that number of times. filling in with zeros. I'm moving up a little bit closer so you can see this, Taylor. Is this a little better, Taylor?
It's fine, Professor.
I'm sorry. I'm trying.
You
So
okay? It's fine.
then we're going from the scientific notation to the standard. Exponent is positive. We move the decimal to the right number, the number of times, and then we fill it in with zeros. If exponent is negative, we move to the left the number of times, and we fill it in with zeros. And we'll do plenty of examples.
Wait a minute, Professor.
Mhm.
But I put it down a little bit. Move decimal to the.
What were you saying, Stephanie?
You said if it's negative, move decimal to the left.
That's when we're going from scientific
Okay.
to standard. That's correct.
Okay. Now, what's the first one?
If the exponent, when we're going from scientific to standard, if the exponent is positive, we're going to move the decimal to the right.
I say filling in what zeros?
Fill it in with zeros.
Oh.
We'll be ready for you in a few minutes, Miss Freeman.
If exponent is.
Give us 5 minutes and then we'll share your screen, all right? So let's do an example of something that's written in scientific notation, and we're going to convert it to standard. Do a few of these and we'll be finished for today. Thank you for your concentration, patience, and everything else. All right? So here's the number. This is written in scientific notation already. How do you know that? You see this times 10 to some exponent. So this is in scientific notation already. So when we write this in standard, we're going to follow what it says. If the exponent is negative, move the decimal to the left. So I'm going to write 3.42, and I'm going to move 4 places to the left.
Okay.
1, 2, 3, 4. And we're filling in those with the zeros. That's what we're filling in with the zeros. So the decimal was here. We move it to the left. 1, 2, 3, 4. So this would be the number in standard notation.
So do we put a zero in front of the decimal?
That would be a good idea. Yes, I would recommend doing that. Yes, you don't have to, but that's good to really emphasize where this decimal point is. Very good suggestion. So this is your standard notation, and we start off with scientific notation. Another example, let's take 3.21 times 10 to the 5th. A number in scientific notation. So we want to convert this to standard. Exponent here is positive. So when we are converting from scientific to standard, exponent is positive, move the decimal to the right. In this case, 5 places. And we're going to fill in with zeros.
321,000.
So here's 3.21. We're going to move it once, twice, 3, 4, 5. And we fill it in with zeros. 1, 2, 3, 4, 5. So we have 3, 2, 1 with 3 zeros. Did you say 321,000, Stephanie?
Yes.
Okay, very good. Yes, correct.
40.
So wherever the decimal is, we're going to move it the number of times that the exponent says. If it's positive, we move to the right. If it's negative, we move to the left.
0 is 5, 4 or 3, Professor? 0, 0. We.
There are three zeros here because the decimal was between the decimal was between the 3 and the 2. So we move it 5 times.
Okay. Yeah.
So we have to fill in with those zeros. Okay, can we show your screen now, Ms. Freeman? Two things I want to show you all.
And you see it.
Awesome, yes, yes. So let's go to the menu. Yes, yes. Yes, Unit 3, Lesson 3. Okay, so let's do one of these where you're given a number that's in standard form. They want you to write it in scientific notation. The first thing I'd like you to do is click that little the box above the X sign over there to the right. Yes,
This one?
right there. So you see how they already put down times 10 to an exponent. So you're going to have to move the decimal so that it's right behind the first integer.
Okay.
And then you write the number, the numbers, not including the zeros, but you write the numbers after that as well.
Okay. So it's 2.6.
And you have to include the 7, yes, be 2.67.
Okay.
You would include any number that's not.
Times 10. 6. 2.67. 10 to the 6.
1, 2, 3, 4. Yeah, I think 6. Yes. Question on that? Freeman?
Yes. Which one you want to go to next?
Oh, let's see what number 3 looks like.
3.
Oh, I like that. Good, good, good. Okay. Now here's what we're gonna do with that. I need you to multiply the 2.1 and the 4.
8.4.
Okay, now what I want you to do is I want you to click on the right above the X like you did before? Yes, okay, good. So we're gonna type in 8.4. So we multiplied the 2.1 times the 4. Now, what should we do with those exponents? Anyone, what do you think we should do with those exponents?
Adam,
Add them, yes. So what's the exponent gonna be?
12.
Well,
Good, good. Because when we are multiplying with the same base, we add the exponents. Nice, nice. Let's look at 4.
Wait a minute, Professor.
Wait a minute, Freeman. Go back to 3, please.
I'll go back to 3. Okay.
Yes.
Oh, so the 10 just stay 10?
Oh, yes, the base stays the same. Yes, the 10,
Okay.
the base 10 stays the same. Correct. Let's go to 4. Let's go to 4. We can do this last one.
Okay.
Okay, now what why don't you click on that above the X? Yes. Okay, now what I want you to do first is I want you to divide those integers.
Okay.
So you can use your calculator. What's 5 divided by 2?
9.
You're going to take the numerator divided by the denominator on your calculator.
Okay.
Mm.
2.5.
Yes.
Okay.
Go ahead and type that in first. Mhm. Now, in this case, we are dividing those exponents.
So you're going to subtract
Correct. Very good. So we can subtract. What goes in the box?
2.
2.
All right. So just remember that when you are dividing, you subtract the exponents. When you're multiplying, you add the exponents.
You want to keep going, Professor? Or no.
Let's do one more. Let's see what 6 looks like.
Okay.
Okay, let's finish off with this. So let's click above the X. Now we know we have to move the decimal just past that first integer. And then we're going to count the number of places that we moved the decimal. And when we're going from standard to scientific notation, and it's a small number like that, we're going to have a negative exponent.
6.9 times 10.
Wait, 3.69. Did you say 3.69?
Yes. Oh, the first number. So, okay. So 1, 2, 3, 4.
4.
10 to the 4.
So when we are converting from standard to scientific, and when we're moving in that direction, we're going from standard to scientific. When we're going to the right, it's going to be negative. Make that -4.
-4. Okay.
Think of it this way: when you have a number like that that's really small, that's a small number. So make sure that your exponent is negative.
Okay.
Small numbers always have a negative exponent. And we're gonna stop it right there.
Okay.
That's most of that assignment. We did half of it. So that's what I wanted to show you for tonight. We'll resume Thursday, okay?
Okay. Everyone have a
Okay, so thanks everybody, and we'll see you then.
okay.